Hello and welcome to another edition of Let's Talk About Informational Stuff. Yeah, so as I mentioned in the Might and Magic 2 video, the one that came just before this one, I got myself a new microphone. And I wanted to talk more about that. Just that I don't want to take up time in the recording talking about things that are not exactly related to it. So yeah, that's why I'm having a different recording. So, a bit of a history here. The first microphones that I used in recording were the ones that come in headsets. And while they worked fairly okay, I guess, they weren't the best. There are a few things that I don't like about headset microphones, and one of them is that when one part of the headset dies, the other part of it also gets fairly worthless, because if your headphones no longer work from the headset, you're not going to continue using that just for the microphone. It would be silly. So you have to just throw out the whole headset, and that's just not efficient. Another thing that I don't really like about headsets is that it can be a bit difficult to set up, and it's kind of easy to breathe into the microphone. So even though I used headsets at the beginning of my recording career, I no longer do so for quite a while. I started using analog microphones after that, and again they worked okay, even though they weren't really that good. The thing is that when recording through an analog microphone, and an analog microphone is your everyday standard microphone that gets connected to the computer using the pink audio jack. So there is one thing about analog microphones that is not very good, namely how it works. So analog microphones work by converting sound waves into analog impulses. And it's done actually mechanically. There is a special thing on the surface of the microphone. There's a certain membrane that vibrates and creates analog signals. Then those signals travel through a wire into the computer. And inside that, a sound card, or sound chip, or whatever, converts those analog signals into digital ones. And then you use digital data to compress things and, for example, record a video recording and add the sound with the video into the video file. So there is one bad thing about this scheme, and that is the fact that the analog signal has to go quite far to reach the place where it's getting converted into a digital signal. And once it does reach that place, there is usually a lot of electromagnetic interference. So, what that means is that some of the signal gets distorted and it becomes simply noise. I didn't know about that for quite a while, and I only figured that out after some time. The thing is that earlier I had the previous motherboard with the previous processor, and they didn't introduce so much noise as the latest one. It was fairly decent and manageable, although it still created too much noise to record without using software noise reduction. And as usual, software noise reduction is not very good. It lowers the quality of the sound, because, well, it just looks at the noise patterns and tries to deduce what your recording should look like when there was no noise. But of course it's not always possible, because it's just guesswork. So yeah. What I did in order to figure out that electromagnetic interference was actually introducing all of that noise into the recording, and not, for example, background noise or something that has to do with microphones themselves, is I tried recording an empty input. Like trying to record the microphone while the microphone is not plugged in. I'm not even sure if Windows allows to do that. I recorded that on Linux, and it does allow you to do that. I suppose if you can trick it into believing that you have something plugged in, even though there is nothing plugged in, then you can do that. But of course I never tried that. So yeah, I tried recording things like that, and lo and behold, what I recorded was a lot of noise. And if there is no microphone, there is no other place that the noise can come from other than from electromagnetic interference. So yeah, that's a problem. And I actually have two sound recording devices, a dedicated sound card and an integrated sound card. Both of them had pretty much the same amount of noise. Also, what didn't help is that the microphones that I was using had very, very low sensitivity. And since the noise that gets added to the sound before it gets processed into digital audio is always static. It's always at the same relative volume. So if you have a very low sensitivity microphone, it gets recorded at a low volume, and when there is a set amount of noise added to the audio, of course that means that the noise to signal ratio gets worse. With the new motherboard, I actually had something like 50% of noise to signal, so that's kind of hilariously much. Yeah, so what I did after that is, of course, try and find out a way to reduce the noise. Now, this new motherboard does have a way to reduce electromagnetic interference. I can choose it in the UEFI settings, but it doesn't really do anything. It still generated the same amount of noise, so yeah, that didn't work. And, well, after a bit of searching, I found out the very good solution. That is, of course, USB microphones. Now, the way it works is a bit different from how analog microphones work. Well, the main idea is really the same, but the location is the key. The USB microphones record audio the same way analog microphones do, but the difference is that it's essentially an external sound card. In my case, and probably in all other USB microphones as well, there is a sound card integrated into the base of the microphone. And that's why the USB microphones usually are a bit heavier than analog ones. Or rather, the analog ones are extremely light. Yeah, so What that does is that the analog signal goes from the top of the microphone to the base, and at the base it gets converted into a digital signal. So it's a lot shorter distance to go for the analog signal, and the place where it gets encoded into digital audio is actually not in the computer itself, where there's a lot of electromagnetic interference, but rather outside of it. And outside, of course, there is literally no electromagnetic interference, unless you have something like, I don't know, your microphone is right on top of your computer case, which probably doesn't happen very often, and even then it would be a lot less electromagnetic interference compared to simply using an analog microphone. So yeah, that means that there is basically no noise introduced into the audio. Of course, there is always background noise, but it's really negligible. The microphone that I have is also very sensitive, and basically what I get is that the background noise is so inaudible that even if I increase the sound level after just recording noise and nothing else, I get basically inaudible noise. There is something, but it's really weak and you can't make it out at all. I guess you can hear it in the recording here as well. So yeah, USB microphones are actually a bit more pricey than analog ones, which is understandable because, like I said, it is essentially an external sound card, so it makes sense. The one that I got is a Logitech desktop USB microphone. I guess that's how it's called. It's literally the only USB microphone that Logitech produces, and it's really good. It costs around $35 if converted to dollars, I guess. So yeah, around that much. So it's not very cheap, but it's not too bad as well. It's not nearly as expensive as some of the professional microphones that you see people use on stage as in, well, on TV and such. So yeah, still quite affordable. And yeah, so that's basically my advice. If you have problems with the noise in your audio recordings, first check if there is a lot of electromagnetic interference, and if there is, you can always get a USB microphone, because it will literally have no noise unless it's defective or something. So yeah. Another thing that I wanted to talk a bit here is about the recordings for My Magic 2. Previously, before I bought myself this new microphone, I used a sound processing technique that is called dynamic range compression. What it does is it equalizes the audio peaks and silent audio segments. So basically that means that the places that were very loud get reduced in volume, and the other places where it's quite silent gets boosted. And I'm not sure what you people actually prefer. Because, well, if I do use it, then you can hear everything quite clearly. Although you don't get to hear, well, places where I'm very excited in as much power as you could otherwise without dynamic range compression. because it's all equalized. But you do get to hear silent parts of the video more. So yeah, like I said, I have no idea what you people actually prefer. I could use either that dynamic compression, or I could not use it. It doesn't matter to me. I would have to play around a bit with the settings of the compression audio feature, yeah, in songs that I used to convert it from wave audio to something that is compressed. But it shouldn't be that difficult if you want that enabled. So let me know. You can just look at the previous Might and Magic videos and see how the volume is there, and compare that to the latest Might and Magic 2 video and see how that looks to you. So if you prefer one or the other, please tell me in the comment section. It would be highly appreciated. So yeah, that's all that I wanted to say here, and see you all next time. Later.